So what does it mean when your check engine light appears on your dashboard? Is it serious? Will continuing to drive do damage to your vehicle? Can you fix it yourself, or do you need to take it to a shop? These are all great questions that many people have asked me when a check engine light appears on your dash. But I know what you really want is answers. And that's where this, or your tablet, can give you the solutions you need for diagnostic repair. The GoTech mobile app pairs with the GoTech OBD2 diagnostic tool via Bluetooth, and it's more than a trouble code reader. GoTech provides easy solutions to complex problems. It's complete with ASC certified technician explanations, giving you the possible causes of the indicator warning light. Let me show you how simple it is. Start by downloading the GoTech app onto your smartphone or tablet, then connect the GoTech device into the OBD2 port under your vehicle's dashboard. With the vehicle on and Bluetooth enabled, which may need to be turned on in the settings screen, you can pair the two devices. Once connected, the diagnostic tool transmits information from your vehicle's computer to your mobile device. It's that simple. What sets GoTech apart is the amount of information you get on the spot. It scans your vehicle and spells out the trouble code, what it means, and the possible causes. GoTech's freeze frame function allows you to email all trouble code details to your inbox or send them straight to your technician of choice. Plus, GoTech gives you real-time digital gauges that monitor engine performance to keep you fully informed. GoTech even offers repair tips from ASC certified technicians, empowering you to fix it yourself, and the ability to clear the code from your engine's computer so you can spend less time fixing and more time driving. GoTech, complex problems, easy solutions.
Hey, welcome to another live Wells Tech training class. We are so happy you are here. I have Mike Becker here with me, and we have a great class for you. But before we get started, yes, let's do this. Let's do the t-shirt giveaway first. Okay, in the class today, you are going to see a wiring diagram that looks very similar to this. And this is for the crank sensor on this vehicle. My question is, what should this box right here say? Remember, this is going down to the PCM. And what is this? What is this? What part is that? Identify that part. Okay?
All right.
First one in with that correct answer will win a t-shirt. All right.
Sounds good.
Here we go. All right. What do we got? What are we working on here,
well,
Mike?
For starters, we have a 2002 Pontiac Grand Am 3.4 liter.
The 3.4.
And it came in,
Been around forever.
Yeah. Came in with a check engine light on for a P0341.
Okay.
And that's a cam sensor code.
Right.
And very, very common on these cars. Identifix had a ton of confirmed fixes of cam sensors.
95 times out of 100?
Right.
It's a cam sensor.
Yep.
They have a lot of problems with the wiring going to the cam sensor.
Exactly.
You know, a lot of stress because the wires are bent over the way they are. And we'll show that today. Actually, we had that experience ourselves.
Right. And also when the intake gaskets, which everybody knows they leak on these things, when that oil and coolant leaks out, it eats away at the insulation on the wires.
Right, it pulls it back, and many times they're shorted.
Right.
Okay, so we replaced the cam sensor.
Right.
Took care of the code, right?
Right, yeah. Well, we hooked the scope up and we had no signal coming out. So then found the bad wiring and replaced the sensor.
And we replaced the sensor. Now, when you replace the sensor, there's a little tip.
Oh,
If you don't know, you need to do this because it'll save you tons of time.
Right, yeah. When you're replacing that sensor, you don't have to unbolt the lines off the power steering pump or anything. Just unbolt the pump and slide it out of the way.
Yeah, just move it out of the way a little bit, and then there's enough room to get in there to pull that cam sensor
Save you a
out.
little time that way.
Yes, and some headaches. I'm sure you pull those lines off the power steering. It's never easy.
Right.
And you can create a big mess. So there's a good tip for you. Just slide it back. You don't have to pull it up completely off.
Right, right.
All right.
So another interesting thing when we were doing our cam sensor replacement, before we went ahead and put the sensor in, like we always talk about, you want to verify your powers and grounds.
Absolutely. Yep.
And so if we look at the wiring diagram here, you can see that we have a 12-volt power and a low reference or ground coming from the PCM there at pin 72 and 73 going to the cam sensor.
Okay.
And so that's what I did. I took our meter, went into power and ground, and I only had 11 volts.
You know, that doesn't sound quite right.
No, it sounds like we have an issue.
And as a matter of fact, if you look at the bottom of that wiring diagram where it goes to the PCM, you see it says 12 volt reference.
We don't have 12 volts there. That's a problem.
We dropped a volt.
Right. Yeah.
That's-
That could be a big deal in
It could
a
be a big
sensor
deal.
world.
Absolutely. So, what was our next step?
Well, went to the PCM then and actually went to the pin number 72 and checked the voltage coming directly out of the PCM. I thought maybe there's high resistance in the wire or something.
Let's make sure the wiring's right.
At the PCM, 11 volts.
Okay.
Well, that's interesting. It's still 11 volts. Okay. So then check powers and grounds going to the PCM. Battery voltage and a good ground. We're all set. So
everything going into the PCM looked right. What was coming out didn't.
right, exactly.
Okay. So it appeared that we had a problem with that PCM.
Right.
You know, and then like you said, those wires. Let's bring up that picture of the cam sensor.
Yeah.
Okay. And you can see where these wires were shorted out.
Right.
Okay. So now you have a short. So did we affect how that PCM is actually functioning?
Right. Yeah.
Okay. Because of that.
Right.
You
Did
know,
you
that
wreck the
overload.
driver or something in there?
Was there, I don't know. They don't tell us how exactly that PCM works.
Right.
And they don't tell our engineers either. That's a secret sauce. They don't leave that information out to anyone.
Right.
The only time we get any information as a manufacturer about how the PCM functions is if we're going to manufacture an OE part, and manufacturing of that part could be affected by how that PCM works.
Right.
It's the only time we get information on that stuff. We don't have the secret sauce recipe here at all.
Sure.
Just like you. And there's no information out there on it because you can't give that. That's proprietary. You can't give that information out.
Right. And I looked all over online and nobody says it's supposed to be exactly 12 volts or battery voltage
Right.
or 11 volts. So we did the next best thing. Brought in a like vehicle. Somebody in the building here had another one.
Right?
Checked the voltage.
And how did it read?
11 volts.
So,
So that must be a known good then.
it must be known good. And that's how they're going to, if you're checking it, and you come across and you get 11 volts, that's right.
Yep.
As far as I'm concerned, that's the way it's supposed to work.
Right. And we put the new sensor in, put it back on the lab scope, and it was working fine.
Right.
So the car's been good to go since then. Just very interesting and not a lot of information on it.
It is. It is very interesting. And when you do run into an anomaly like that, it can be very confusing. And for guys in the shop, I mean, are they going to spend that extra time? No, the vehicle's running good. The check engine light hasn't come back on. Everything's back.
Or would they have put a PCM in here? I was ready to condemn the PCM.
And I was too. And would they just throw a PCM in?
Right.
And thinking that because of the shorted wires, that's what ruined the PCM.
Right.
You know, so be careful. And that's why we did the further search on that is we weren't sure where we were. So there you go.
Exactly.
Put that one back in, you know, in your belt of knowing knowledge.
Right, exactly. Well, all right, so that's just kind of the tip of the iceberg for this class.
Yes.
You know, when we brought up the diagram here, it's kind of a different, there's a lot more aspects to this car than what we're used to seeing. This car's got 2 crank sensors and the ignition control module.
Right.
So
2 crank
kind of-
sensors, cam sensor,
Right.
and an ICM.
Right, and that's common for the GMs of this era, the 3.8, the 3.1.
Right.
You know, it is common for these, but it's kind of an anomaly in the automotive world to be running the two crank sensors. So why don't we
Especially
talk
today.
about that? Yeah,
Right.
yeah.
Yeah. So there's a 7 times crank sensor and there's a 24 times crank sensor.
Right.
Okay. So
The 7 times is on the back of the block, 24 times on the harmonic balancer.
yeah, can we bring up that diagram that
Yep.
shows us? Okay, there's the 7 times trigger wheel. Okay, and on that you can see that there's 7 notches, and 6 of them are evenly spaced apart, 60 degrees apart.
Right.
And then there's 1 notch that's 10 degrees away from another one, which tells it number 1 cylinder is at top dead center.
That's the trigger
Okay,
for it.
That's your trigger.
Okay.
That's your sync.
Okay.
That's to let it know right where the crankshaft is located.
Sure.
And then as we go around the wheel, you can see that it skips a notch, and the next one is 3 and 5, 3 and 6, whatever. I can't read it. 3 and 6. and then the next one is 2 and 5, cylinders
Right.
2 and 5, because it's a DIS engine, so you're firing 2 cylinders at the same time.
Exactly.
Okay.
Right.
So, and that is also a sine wave.
Right, yeah. If you
That's
see in the
a-
diagram here, it's only a 2-wire sensor.
Right, it's a 2-wire sensor, so you're sending that sine wave to the ICM. And what the ICM does then is it has an analog to digital converter,
Right.
an A-to-D converter internally, and it converts it to a digital signal. And what does it do with that signal then?
Well, and that's interesting. So really, the 7 times has no direct relationship with the PCM.
Correct.
It goes to your ignition
Yes.
control module. It does the converting, and then it sends a 3-time signal back to the PCM. So
Right.
ignition control module to the PCM is a 3-time signal, or what's referred to as a low resolution.
Low
Signal.
resolution or an RPM signal,
Right.
that type of thing.
Yep. So that's interesting.
Okay, so then the ICM sends that signal to the PCM.
Right.
The PCM takes that information once it's in closed loop, right? And takes that information and from the ICM and the other sensors,
Right.
okay, that's looking at, and then determines where ignition timing should occur.
Right, and at that point, then the PCM would take over ignition
Right.
timing, where before it's made its decision, the ICM actually has full control over ignition timing.
Right. And what it'll do then is through the IC timing signal,
Yep,
right,
yep, it'll send that signal back.
send that signal back and tell the computer when to fire those coils.
Right.
Okay. All right, so now we also have a 24 times,
Yep.
which is interesting. Okay, what does that do?
Well, that's a 3-wire sensor, and that's the one mounted actually on the harmonic balancer pulley. The trigger wheel is, but the sensor is mounted to the front cover. But this sensor is going to monitor the revolution of the crank. It's got 24 evenly spaced windows or triggers,
Right.
and there's no sort of sync or keyway or anything on there that has a set difference like on our 7 times does.
Right, where our 7 times you have the 2 that are 10 degrees apart.
Right, yeah.
And the ICM knows, hey, that's my signal to number 1 cylinders,
Right.
top dead center, that type of thing. But
Right.
there's no indication or any sync on that front crank sensor
Right.
24 times.
Right, which is interesting, and we had to really dig in deep and look to see what exactly that 24 times is actually doing on there.
Right.
And according to what we found out on all data, it says the 24 times sensor is used to help enhance engine smoothness and idle stability.
Which is interesting. So it's a fine tune.
Sure.
You know, when you got your knobs on your radio, you got the big knob and then you got your fine tune knob.
Right.
That's your fine tune knob.
Right.
Which is interesting. What kind of problems do we have when the 24 times goes out?
Well, the 24 times is also used to monitor misfires.
Okay.
So the computer's going to read the timing between each of those teeth and monitor for misfires. So if you have a problem with the 24 times sensor or the harmonic balancer or something, you could have false misfire codes. It could possibly not register a misfire. And now I've heard some drivability issues could happen because of this, maybe a little bit rougher of an idle or the engine runs a little bit rougher.
Kind of a fine tuning thing.
Exactly, yeah.
Okay, where you feel a vibration.
Right.
You could have some sort of issue going on there. Okay.
But not obviously it would set a check engine light, but the vehicle would still run without that one plugged in.
Which is interesting. Okay, so we're running, but we're not running as efficiently as we could.
Right.
Okay, is the way. Plus, if it's not plugged in, are we going to see a misfire?
Probably not.
Probably not. Okay. All right. So,
Let's should we talk about the variation relearn now? That kind of had us thinking for
it did have
a
us
couple days
thinking,
here.
and you know, there is a variation relearn that when you do install 24 times, it's recommended to do this relearn.
Right.
Okay. And we also have run into, in our research, we found guys that were replacing that harmonic balancer and running into issues with that.
Right.
Okay. And maybe what we should do before we get into that is bring up a couple examples of harmonic balancers that are available
Okay.
in the aftermarket.
Okay.
We don't manufacture one, or we don't sell one, but bring one up there.
Okay.
And let's see what that looks like. Okay, there's one of them, and you can see the keyway there is pointed on this one, is pointed right at one of the trigger dividing windows, and the divide between the windows.
Right.
Okay, and it's almost directly right at it. Bring up the next one.
All right.
And you can see with this one that it's off a little bit. It's off to one side a little bit, and that was the complaint that we were hearing on IETN.
Right.
Was, you know, they would put an aftermarket harmonic balancer on, and we'd get a check engine light because of it.
Yeah.
And to cure the problem, they would do a crankshaft relearn.
Right.
Okay?
Yep.
And this is probably why. And does this make a difference? Does it run different? That's a great question.
Okay.
I am not sure whether or not this is going to affect long-term drivability.
Right.
You know, is there, you know, if you have one that is not sunk exactly the same as the original equipment one, but you can do a relearn, okay, tell it that now this signal that it's seen is correct, okay, is that going to do long-term problems? Like, is your emissions going to be higher, your fuel economy going to drop, maybe your power isn't,
Sure.
you know, exactly
Yep.
right? You know, I don't know. And maybe you guys can help us with an answer. If you put on these harmonic balancers and, you know, done a relearn, is there any long-term,
Sure.
you know, result from that?
Right.
So,
Yeah, because each window on there is 15 degrees apart. You know, you have 24 windows on a 360 degrees. That's 15 degrees apart.
right.
I'd say this one's maybe three degrees off, 2 to
Yeah,
3 to 4.
you know, just by eye, it
Yeah.
looks like it's just a few degrees off. Does that matter? I don't know.
Right.
I'm not sure.
Right, and there's really no definitive information that I could find. It's kind of a perform the relearn and it'll take care of your problem type of thing,
Right.
but nobody says what exactly it's doing. And from the most information I could find, they were saying that the relearn is taking those 24 pulses and making sure they're all evenly spaced and verifying there's no manufacturing flaws or defects or
Right.
indiscrepancies in those 24 pulses.
If they're not evenly spaced,
Right.
you know, if you have some that are tighter than others, that would indicate that you have a misfire.
Right, yeah, the crank's slowing
The
up or
crank is
speeding
slowing
down.
down and speeding up. Right, that type of thing, and that's what it's looking at. And I understand all that, but it's also using it to fine tune your injectors.
Right.
You know, is it really doing that? Is it really doing a lot? That's my question.
Right.
You know, if it's doing a lot, well, that 3 degrees might make a big difference.
Well, that's just it, yeah.
You know, but if it's not doing a lot, which I suspect, it's kind of like they say we're doing this
Sure.
kind of thing, and it's just a little bitty bit, you know, kind of thing. It's not going to make a difference, and that's what I suspect is really happening here.
Right.
But that's just speculation.
Yeah, it's very interesting, and
Okay, it is. Why don't we bring up, you know, in our research, we went out on IETN and we went out on all data and we looked at different scope patterns and things like that, what guys are posting with problems that they've seen, different things like that. So let's bring up one off of a 2001 Pontiac Grand Am, and it's showing your crank sensor, your cam sensor, and your ignition primary wave, okay? And if you look at that, the blue line right there is your primary
for the ignition, yep.
for the ignition.
Yep.
And then your 7-time signal, you can see that is on your red.
Yep.
And the interesting signal that this fella posted, and by the way, he's posting this as known good values.
Right.
And that we've got there. And why don't you go to the next slide, and that'll draw that out completely.
There.
Okay. What's wrong with that?
Well, it's interesting because there could potentially be 2 problems here. One being, we know that this is a digital sensor. So a digital sensor is a low to a high back to the low. It should be a square wave.
Yeah, that is correct.
You can see here that that's not a square. Somewhere we're losing the power, or our ground is not right.
It's the ground is what's
Right.
wrong here. And you can see that when it comes down after it does the, comes across the top and comes back down, it goes lower than what our ground value is.
Right.
You know, that's telling me that you know, you always have somewhat of a floating ground. You're never right on zero, and the reason for that is for noise. It helps cut down noise and stuff. But here, we've got a bad connection in here somewhere. Somewhere, something has a bad ground because it sunk ground, it looks like correctly, after it had, after the signal, the second half of the signal went below.
And actually, that might not even be the full signal.
Because it doesn't look like the full signal.
When we scope it, and we'll show you guys in a little bit here, but when we scope it, you'll see that the signal lasts a lot longer.
Right, that signal should go for the whole one full cycle of the crankshaft is what it should look. Because on the camshaft, you just got one trigger.
Right.
That's all it is. Trigger on, boom, trigger off. And it's the whole rotation of the crankshaft. You'll see on a good pattern here coming up. But interesting stuff. And the point here is, you know, if you guys are going out looking for information, and just like we talked about last time, you know, when you're reading diagnostic information and steps to diagnose a car, be sure you know what you're reading.
Right.
And here, be sure you know what you're looking at, or at least have a good idea what you're looking at. And unfortunately, if somebody didn't have any experience with scopes, and they did not have that scope pattern on their scope while they were working on it, they would suspect something else is wrong.
Right.
And could be jumping through hoops for nothing.
Right, yeah, so just don't follow the information blindly. Make sure you know what you're looking for and what you're looking at.
Yep. And okay, do we have a good pattern here? Bring up?
Yeah, so here's a good pattern.
Okay, there, go back one.
There we go.
Right there, yep. Okay, and that is a good pattern. That looks like a good pattern. We've got our cam signal up on top, and you can see it goes through the whole cycle of the crankshaft.
Right between those two trigger points, or the sync points.
The sync points there on your 7 times.
Right.
And once you see a sync point, you see another sync point, that's a complete revolution.
Right.
And then our 24 times is below that, and it looks like everything is the way it's supposed to be.
Yeah.
The way it's lined up.
Yeah, so this, we could take this as a known good. This looks awesome.
Yes, I would accept this as a known good. But be careful. Be careful when you go out there and look. Okay, what else do we need to talk about before we go to the car?
I think we pretty much covered everything that I wanted to talk about.
Okay, all right, so let's go on over to the car. And what we're going to do is we're going to go through it kind of slow, because what we want to show you is exactly how we set up our scope.
Yep.
Take you step by step through that. So let's go have some fun.
Let's go play.
All right.
All right.
Good stuff.
Okay. Here's our 2002 Grand Am.
All right, our little nemesis here.
Yeah, this was a fun one.
All right. First thing we did, the 2002 Harmonic Grand Am 3.4.
Yep.
Right? Okay. First thing we did was pull the codes.
Right.
Right?
Yeah.
When we pulled them, we did it a little different this time. Not with the scan tool. We did it with
our GoTech.
With our GoTech.
Yeah.
Yes, and here it is. You just take this little dongle, you put it into the ALDL, and it'll communicate with your iPad or your cell phone.
Right, exactly.
However you have it set up.
Yep, so I went ahead and pulled the code, and if we bring that up on the screen here, you can see that we're getting a P0341 camshaft sensor performance code. It's talking about the ECM detecting an incorrect correlation between the cam and crank sensor. And what really helps to set the GoTech apart is the fact that it offers these confirmed problems or errors or common errors. Yeah.
Right. You know, when this code sets for this vehicle, it'll list most common errors.
Exactly.
So you have a direction for repair.
Right. So like this one talks about checking for other trouble codes to see if you have a possible fault code correlation, like a crank sensor or something like that. Possible damaged wiring harness, which we had. Possible faulty cam sensor, possible faulty cam sprocket, or faulty computer, faulty PCM.
Yeah, that's really cool. And like I said, it'll send you in the right direction.
Yeah,
another cool thing about this thing is we entered it. It was entered into the Apex new tool, and it won new tool of the year of the
best new product. That's awesome.
Very cool stuff. Very cool stuff. And I just got word from upstairs.
Yeah?
You're not going to believe what they said.
What?
They said they want us to give away one.
Awesome.
Yeah, they want us
that's
to
cool.
give us one away. Perfect.
Let's do it.
So what we're going to do is everyone who sends in a guess for the question, all of you, no matter if it's correct or not, will be entered into the contest.
Sure.
Okay, we'll put all their names into a hat, we'll pull one out, and next time we'll announce the winner.
Right. Well, that
Okay.
sounds good. Good luck.
So there you go.
All right. So why don't we get into this thing?
Yeah. let's do it.
So we have cam sensor problem on here. So why don't we go ahead and show how to set up the scope and scope it?
Okay.
All right. So I have our leads here, and remember when you're using your scope, you got to be hooking up that ground lead. So I'll do that first. Hook up our black lead right to the battery negative, and then you want to hook the other piece of this into the signal circuit. And just to verify, we'll go over to the wiring diagram and just make sure we got the right one. So signal circuit out of the out of the cam sensors on the brown and white wire goes down to our PCM right there. So we'll back probe pin B, brown and white. So we'll hook right here's our cam sensor. We'll hook right into the back of that. And there we go. And then hook the other end of our leads up to this scope. Now remember, when you hook up the scope, you have to have ground. So I'll hook the black wire into there, which goes to our battery negative, and then the yellow lead into channel 1. And now I chose yellow for our lead. We have a bunch of different colors, but yellow is the channel 1 color. So when we get more leads on here, more channels working, it helps us stay organized that way.
Yeah, you can discern one from the other.
Right. So now, if you want to go ahead and fire this thing up, we'll see how it looks on the scope.
Okay. Are we clear?
Yeah, so we got the scope up on the screen here. And we're not really seeing much here. We saw a little glitch or a little glimmer there again. But we're not really seeing anything. Okay, I'll go ahead and you can shut it off for a minute.
Okay.
So right now we're at a really fast interval, 0 to 1 millisecond. And we're at 0 to, it says 16 volts up here. We're on a 20 volt scale. If you look here, there it shows we're at 20 volts, 1 millisecond for our time. And now we're not really being able to pick anything up at all here. So what we want to do is set up a trigger for the scope. So we'll go to our setup button right here, and we're going to tell the scope where to look for our pattern. So we'll go trigger, trace 1, leave it on auto, and press exit here. And you'll see we get this crosshair symbol right here. We can move this thing around, just click on it, move it around. And this is going to tell the scope where to look for the signal. So I'm going to put it right up here at, we'll go 10 volts, right in the middle of the screen. So why don't you go ahead and start it up again, and let's see what that looks like.
All right. Clear?
Yep. And you can see immediately it looks a lot different. The trigger is picking up the signal and putting it right on the screen. If we move this thing up or down, it adjusts where it sits. We can bring it back here. So that looks very nice. All right, I'm going to stop it here. All right, you can shut it off. So by setting this trigger, you can see really easily now what's going on with the cam sensor, but we don't know the full story because we're zoomed in way too tight. But this does show something interesting here, and let's talk about that a little bit. It's not a square wave.
No, it's not, and that shows that it takes time to make that signal.
Right.
You know, it isn't. You look at it normally and it looks like a straight line, but it really isn't. Right. You know, if you take the measurement of time and you knock it down low enough,
right,
it's going to show a curve.
Yeah, and
Almost looks like an amperand.
Right, 0 to 1 milliseconds is super fast. So what we can actually do here is if you click on your magnifying glass button here, we can zoom, and we'll zoom this all the way out. And there, right there, now we're at 0 to 262 milliseconds. And you can see we have our square wave pattern.
Right.
But this is still, this almost seems too far out that we can't tell exactly what's happening. So we'll go back to zoom, and we'll go somewhere in the middle. Let's go 16 times. And now we have nothing because we have to scroll through a little bit.
That looks pretty good.
There's our cam signal right there. We'll move this out of the way. So there's our cam signal right there. That's our known good cam signal.
Right. And that looks like a pretty good signal.
Yeah.
Now, last time we were out, we saw there were some hash marks coming down here, and we actually had one spike that came way down here. Does that matter?
Yeah, it possibly could if it goes down far enough.
You have to, you know, if you didn't catch our other classes, you might want to go back and look. In one of our classes, we talked about the 80-20 rule.
Right.
And that's where this really comes into play. If we go back to the screen here, you can see what we're talking about is the computer doesn't look for this angle right here.
Right.
What it's looking for is a raise in voltage. So once the voltage reaches this level, that's a trigger on.
Right.
Right. This is another trigger on.
Right.
This is how long it's been on.
Yep.
And this is off over here.
Right.
So when you get some hash marks in here, unless they're really spiking down into that area, it really doesn't affect it.
Right. This little bit doesn't do anything, but if we brought it down all the way to here and back up, that could
very
be a
possibly
trigger point.
could. I would be concerned about that.
Right. Yeah.
Yes. Absolutely.
And with the hash marks here, we ran into a few weeks ago. We were using a different power supply for the scope.
Right.
Just a two-wire power supply without that third ground terminal on it.
Oh yeah.
And we were getting almost half a volt of hash here just as interference in the scope.
And that's a good tip.
So we changed the power supply to the grounded style three-pin connector into the wall there, and it went away. And now we have almost zero interference.
So a 60 cycle hum.
Yeah.
Right.
Yeah. So you got to watch out for that. That
Yes,
could
you
really
do.
throw you off.
Okay. Very good.
So this
Good
is
stuff.
a good pattern and everything, but it's not really telling the whole story of what that
No, it
engine's
isn't.
doing.
It's just a cam signal, and we don't know if it's actually coming on at the right time or going off at the right time at this point. We know that the cam sensor is sending out a signal, but that's all we know at this point. To find out, we need to look at the cranks, right? And you're also going to look at the 3 times.
Right, exactly.
And guess what? We're going to do that next time out.
Yeah.
As a matter of fact, we're not going to have a classroom next time.
Right.
In 2 weeks, we're going to start right on the car, and we're going to show you how to set up your scope for those patterns so you get the right result that you need. And
right, just seeing here if
Did we get anybody in with the correct answer?
Doesn't look like we have anybody answering today.
Well, you better answer. Send something in order to get into the drawing for the GoTech.
Right.
That's cool.
So,
and by the way, if you want to go out and buy a GoTech, you can find them out on Amazon. They're available.
So if anybody's having any issues commenting, why don't we go ahead? There's the email address.
There's my email address. Please send me any comments in, and we'll be sure to answer.
Yep.
Okay.
All right. I think that's,
anything else you'd like to add?
I think that's it for me for today.
Okay. That looks pretty good to me too. All right. Very good. And by the way, we're going to do a voltage drop. We're going to show you that voltage drop that confused us last time. And your homework for this week is to look at a like vehicle and see what measurement you get. See if you get 12 volts or 11 volts. Okay. Yeah. We got 11 on 2 vehicles. See what you guys get. Let us know. I'd appreciate that. Okay. That's it. Without you being there, we would not be here. We do appreciate it. And we'll see you again next time in the Wells Tech Garage.
We'll see you then.